So welcome everybody to this latest A2 video on 162 Maths, and in this video we'll be introducing series and sequences and starting off by going through arithmetic progressions, also known as APs, and working through finding and using the nth term. So an arithmetic progression, also known as an AP, is a sequence of numbers in which any term can be obtained from the previous term by adding a certain number called the common difference. Now the first term of an AP is denoted as the letter A and the common difference is denoted as the letter D. So if we take an arithmetic sequence, so let's just start off with writing A, then our next term, so all we're going to be doing is adding D to it. Now D could be positive or negative, again it doesn't really matter, so then the next term would therefore be A plus D. And then obviously if I then continue to add another common difference, then the third term is then going to go on to be A plus 2D. Add another difference, and the fourth term is going to be A plus 3D. And again, so on. If I add another D, we get A plus 4D. Now the key thing to note with regards to this is that this here is our first term, this is our second term, this is our third term, this is our fourth, and this would be our fifth term. Now one thing that we should be able to spot from this is that the number of terms and the number of D's is always one less. So we're trying to find a relationship between how many D's we've got. So in our third term we've got 2, in our fourth term we've got 3, in our fifth term we've got 4. So without doing any much calculation, we can see that in our 10th term what the formula would look like is A plus 9D. Now that allows us to generalize into a general formula for an arithmetic sort of progression in the form of similar to what you may have done in linear sequences with finding the nth term. Now this formula is given to you in the A-level exam and is given in the form of a formula book, but obviously we still need to practice on how we actually use it. Now the UN is basically the value of the term, at n. And obviously A is our first term and D is our common difference as previously mentioned. Now n-1 is just allows us to figure out what our value of D is going to be, or coefficient of D is going to be, and which can be easily done as we've already showed. So looking at its first question, it says that an arithmetic sequence starts 4, 7, 10, and the first part of the question is asking us to find the nth term. Now an AP is very similar to a linear sequence, so if you can spot what the nth term is going to be in your head, then that's going to be absolutely fine. And if you remember what you've been taught at Key Stage 3 or GCSE, we would notice that just by looking at it that the formula for the nth term is going to be 3n plus 1. Well, let's have a look at how we can use the formula, the general formula for an AP works for this. So in terms of 1a, we're going to use the formula of a plus n minus 1d. So looking at the information given to me in the question, I notice that a equals 4 and the common difference is going to be positive 3. If I then substitute all of those components into the formula, I get 4 plus n minus 1 times 3. Expand the brackets out, I get 4 plus 3n minus 3, which then leaves me with an nth term of un equals 3n plus 1, or if you wanted to you could write 1 plus 3n. Either of those two would be absolutely fine. Now to find our 46th term, well that's when n equals 46. So all I need to do is substitute 46 into this formula. So it's going to be 3 times 46 plus 1, which again, if I work that out on my calculator, so 3 times 46 plus 1 gives me an answer of 139. Now for C, to work out C if a number appears in a sequence, then all we need to do is make the number equal to the nth term. So here I'm going to write 3n plus 1 equals 2364. Now if the number appears in the sequence, then n would equal a whole positive number. Now if it ends up being a fraction, then it's definitely not going to be in the sequence. So here all I need to do is solve this equation. So I've got 3n equals 2363, and then divide that by 3, and I get n equals, so 2363 divided by 3 gives me an answer of 787.6 recurring. So therefore 2364 does not appear in the sequence. And it's really important that you do write that final statement rather than just leaving it as a decimal number or as a fraction. Because you always want to, if it's a prove that question or it's asking you a question, always make sure you do answer it in words or with some proof. So now let's have a look at our second type of question. So in our second type of question, it says that the fifth term of an AP is 24 and the ninth term is 4. So we can notice straight away that potentially that this arithmetic progression is going to be decreasing. And the question is asking us to find our 35th term. Now the first thing we want to do here is find the nth term. Now to do that, what I need to do is use the information that's given to me. So when n equals 5, un equals 24, and when n equals 9, un equals 4. So what I'm going to do is I'm going to translate that into our formula. So here I've got a plus, and then it's going to be 5 take away 1 d equals 24, and then I've got a plus, and then it's 9 take away 1 d equals 24. If I then go on to simplify those and expand the bracket, well, I don't need to expand the bracket. So here I end up with a plus 4d equals 24, and here I get a plus 8d equals, not 24, don't know where that's come from, let's change that to 4, equals 4. Now from that, what I then want to do is turn this into a simultaneous equation question. So I've got a's, so let's just cancel that by taking away. So I end up with minus 4d equals 20. So therefore d equals minus 5, which is kind of expected because we can see that the sequence is decreasing. Now from this I can then work out what a is just by substituting my value of d in. So here I've got a plus, and it's going to be minus 20 equals 24. So a is going to equal 44. And so what I've got as my nth term then is the nth term is going to be 44, and then it's going to be minus, also I say plus n minus 1 to the power of minus, or not to the power of 5 times minus 5. And then if I then go on to simplify, expand the brackets, I get 44 minus 5n plus 5, which then gives me 49 minus 5n. So there is my nth term. Now from this, because the question is asking me to work out the 35th term, so therefore when n equals 35, I'm going to do 49 take away 5 times 35, put that in brackets. Again, just simply plug that into my calculator. So 49 take away 5 times 35, I get an answer of minus 126. And there we go.